Okay, good morning. We got solving systems using elimination. The objective is to solve systems by adding or subtracting to eliminate a variable. Okay, so this is another way to solve for x and for y, and it's just a little bit different than substitution. First thing you want to do is make sure that the variables are lined up vertically. So when you see this one here, you have the 2x and the 6x. Make sure they're on top of each other. And then the same thing with the y's, and then you have the equal sign, and then your constants are also on top of each other. So I'll write it over here. All right, so step one is done. We have everything lined vertically. Step two is decide a letter that's the easiest to eliminate. Now, something eliminates if it equals 0, such as, let's say you take a positive 2 and put it together with a negative 2. Positive 2 and negative 2 equals 0. In this case, you look at the x's, I see a 2 and a 6. You look at the y's, I see a positive 5 and a negative 5. Now that catches my eye. A positive 5y with a negative 5y equals 0y. So those are the variables that are going to eliminate. Once you have something like a positive 5 and a negative 5, draw a line underneath the problem, and then we're just going to add. Together we'll take 2x plus 6x to get 8x. 5x plus a negative, 5y plus a negative 5y equals 0, so that eliminates. You don't have to bring anything down. Bring down the equal sign. 17 minus 9 gives you 8. Divide by 8. Divide by 8. X equals 1. And we're almost done, guys. Now, just like substitution, we have to solve for y. Now, with elimination, getting the second variable is just a little bit harder, a little bit more work, but not too bad. Now, we want to solve for y. Let's go back to the original equations. When you look at this first equation here, and then look at the second equation, you just have to decide which one has the easier numbers so you can plug in a 1 in place of the x. It looks kind of like the bottom equation might be just a little easier, but it's about a horse apiece. Some students like the top equation just because it doesn't have any negatives in it. So let's take our 1, put it back in place of x right here, and let's see what we get. So 6 times 1 minus 5y equals negative 9. 6 minus 5y equals negative 9. Moving the 6 to the other side, we'd have minus 5y equals negative 15. Divide by negative 5. Divide by negative 5. Y equals 3. So my two answers are x equals 1 and y equals 3. Okay, letter A here. I make sure everything's lined vertically. You know, you see how the x's are on top of each other, the y's are on top of each other, and then you have your constants. I look at the x's and I notice that one's a 5x and the other's a 3x, so they don't eliminate. But the y values do. You have a negative 6y and a positive 6y. Now, when you have that, you draw a line, and then we're just going to start adding. So 5x plus 3x gives you 8x. The y's eliminate. Then you take 48 minus 32, get 16. Divide by 8, divide by 8, x equals 2. Now we're almost done. We have to find the equation that's a little bit easier. And again, students are probably going to be drawn to the second one here because of all the positives in there. So take your 2 value, put it in place of the x right here, so we can solve for y. And here's what we'd get. We'd have 3 times 2 plus 6y equals 48. So my two answers, x equals 2, y equals 7. Got my two answers, and that'd be correct. Now I'm going to erase this part over here so we could just take a look at B. I'm not going to finish it, though. Now, it's the last two problems, the y eliminated. I just want to make sure you guys know it's okay for the x's to eliminate. On letter B, make sure everything is aligned. The letters are on top of each other in the right spots. So I see a negative 3x and a positive 3x. Those will eliminate out. I'd put together our y's. A negative 3y plus a negative 4y is negative 7y equals 9 plus 5 will give you 14. And I won't finish it, but that's the idea. And then you would solve for y, get your answer, put it in place, and then get your x value. Okay, we'll skip the word problem for now. During class, we will go back to the word problems. All right, now this one's just a step up from the other problems. Okay, so I look at the variables, making sure they're aligned. I have the x's on top of each other vertically, so are the y's, and I have the equal sign with my constants at the end. The x's don't eliminate, and neither do the y's. So now you just have to think, how can we get them to eliminate using multiplication? Now, here's what's going through my mind. I'm drawn to the y's because I know a number that 15 and 5 both go into is 15. If I would multiply by the bottom equation by 3, and I'll put it out front like this. If I would multiply the bottom equation by 3 and distribute it to every single one of them, here's what you'd get. The top equation would stay the same, minus 2x plus 15y equals negative 32. But the bottom equation would turn to this. 3 times 7 gives you 21x. 3 times negative 5 is negative 15y. 3 times 17 is 51. Check out the y's now. I have a positive 15y on the top and a negative 15y on the bottom. If you add them together, you'd get 0, therefore they'd eliminate. Now you might ask, well, why didn't I work with the x's at the beginning? I could have, a number that negative 2 and 7 both go into is 14. I'd have to multiply the top by 7 and the bottom by negative 2, which would have been just a little bit more work, but definitely doable. All right, so let's get back to this bottom part here. Negative 2x plus 21. X would give you 19x. The y's eliminate. Putting these two together, we got 51, subtract 32. Let's see. 19, divide by 19, divide by 19, x equals 1. Pick the equation that looks like the easiest. Kind of looks like the bottom one's probably a little bit easier, so we take our 1, put it in place of the x by the 7. So we have 7 times 1 minus 5y equals 17. Y ends up equaling negative 2. Okay, and this one here is another one that makes sure that the variables are lined up one on top of the other. And everything's good to go. Okay, so just look at the x's, look at the y's, and think to yourself which one's a little bit easier. It's about a horse apiece. So if you think of a number, let's say we work with our x's, between 3 and 4, a number they both go into is 12. Now let's look at our y's. Between 2 and 3, a number they both go into is 6. 6 is a little bit smaller, maybe a little easier to work with, so let's go with that. Now, if we want to get to 6, we'd have to multiply the top equation by 3. So that my y value would be 6y. Now, I have to multiply the bottom equation by negative 2 because I want the top to be a positive 6y and the bottom to be a negative 6y. Therefore, they'd eliminate. So here's what you'd get after you run that through. 9x plus 6y equals 3. Remember, it's every single term. It's like distributing every single one. Same thing with the bottom one. Minus 8x minus 6y positive 4. All right, so check out the y values. The plan worked out. I have a positive 6. I have a negative 6y. So I just put things together. 9x minus 8x gives you 1x. 3 and 4 give you 7. Pick the equation that looks like the easiest one. In this case, the top equation is the easiest one. Putting 7 in place of the x, you'd have 3 times 7 plus 2y equals 1. And y ends up equaling negative 10. Okay, so this would be on day 2. The main thing on this one is that we talked about these having one solution, like on this previous problem. This is one solution. Even though you get x equals and y equals, remember, that's just a point where the two lines cross. We also talked about many solutions and no solution. No solution if the lines are parallel. Many solutions if the lines lie on top of one another. So on this problem, I'm looking at the x's right now. I see the 2x on top and I see the 1x on bottom. Whenever you have a 1x, they're pretty easy to change because if the top's a 2, you can easily get the bottom to be a negative 2 if you multiply negative 2 throughout every single term there. So here's what it would look like. The top equation would stay the same. 2x plus 6y equals 18. So the top equation didn't change. But if you run that negative 2 through the bottom, you'd get negative 2x minus 6y equals negative 18. Now, you draw the line. Our plan worked. The x's do eliminate. So that equals 0. That's out. A positive 6y and a negative 6y, well, that also equals 0. So I have to at least put something on the left-hand side. So I got to bring down a 0 equals. And 18 minus 18 is also 0. Remember in class we said that if the left side is the same as the right side, this is many solutions. If you try a problem and you'd get like 3 equals 4, that would be an example of no solution. All right, that should be everything. We'll work the word problems in class, and good luck.